So yeah, earlier when we were talking, we're asking about what to look for, how to figure out what equation to use. So in question 33, we're given this reaction. Nitrosyl chloride breaks down into nitrogen oxide and chlorine gas. And they tell you it's a rate law is second order with respect to nitrosyl chloride. And so what that means is rate equals the rate constant times nitrosyl chloride squared. That would be a second order reaction. They tell you that the rate constant for that reaction equals 3.2 inverse molar inverse seconds. That's another clue that it's second order because we know the units of rate constant depend on the order of the reaction. Initial concentration is 0.076 molar, and they're asking for how long would it take for nitrosyl chloride to get down to a 0.042 molar.
How did you know it was second order?
I knew it was second order because in question 33, they said the nitrosyl chloride has a rate law that is second order with respect to the nitrosyl chloride. And they gave us the rate constant. The units of rate constant are for a second order reaction. Inverse molar, inverse seconds are the rate constant, the units on rate constant for a second order reaction. So both of those things combined tell us it's a second order reaction. So now that we know that, we know our initial concentration, our concentration at some point in the future, we can find our time. So for a second order reaction, right, 1 over concentration at time t equals kT plus 1 over my initial concentration. So here is AT, here is A0. So 1 over AT 0.042 equals my rate constant, 3.2 inverse molar inverse seconds. Time is my unknown in this case, plus my initial concentration, 0.076 molar. So divide those two, all right, 1 divided by 0.042, get 23.8 equals 3.2 1 divided by 0.076, 13.16. So subtract 13 from both sides. Let's see, 23.8. So 10.64 equals 3.2. We're going to divide both sides by that 3.2. And my units here, right, we're inverse molar. My units here, we're inverse molar. So divide by 3.2 inverse molar. And that cancels out. And so 10.6 divided by 3.2, I get 3.3 seconds for my change in time. So that's good practice in like breaking down one of those questions, realizing it's second order. They tell you second order. They also give you the rate constant. So knowing that those units of rate constant are those of a second order reaction. And then from there, just plugging in, well, we know our initial concentration. I know my concentration at some point in the future, and I know the rate constant, just going to solve for T. And so from there, it's just using that equation and working through the steps to find our time for that reaction. And then once we have question 33 done, question 34 from the previous question, what will be the concentration of nitrosyl chloride after 125 seconds? So now, it's a little bit different in that right now we're looking for, okay, 1 over my concentration equals my rate constant, 3.2. My time now is 125 seconds. And then rather than, here's my 1 over my initial concentration, I know that's 13.16. So I'll just plug in 13.16 there to save myself the time of working through or doing that division again. So 3.2 times 125 plus 13.16. And I'm going to just bring this down here. I get 1 over my concentration at 125 seconds equals 413. So multiply both sides by concentration. I get 1 equals 413 times concentration. Basically taking the inverse, right? Divide by 413. And I'm going to get my concentration at time t equals 2.4 times 10 to the minus 3 molar. So we could have done, we could have done question 34 without question 33 because, they already gave us, we already knew the rate constant for that reaction. But both of these are good steps because T could be an unknown, right? We could solve this equation for T. We could also solve this equation for, what's the concentration at the future based on rate constant, based on time, based on initial concentration. So yeah, you should be comfortable kind of solving for any of these variables in these equations.